Alright, so here's the video of me doing the test review. I know this is going to be kind of long. I'll do my best to be quick and thorough explanation at the same time. So this first one, we're adding. So make sure you're paying attention to what I'm asking you to do. So this first one is asking you to add. So when we're adding rational functions, we need to have a common denominator. So we don't need to worry about factoring the numerator when we're adding and subtracting, but we do need to factor the denominator. So x squared minus 4, so this right here, we need to factor. I'm going to skip the factoring work for time purposes. So we need to factor x squared minus 4. So after we factor x squared minus 4, that gives me x plus 2, x minus 2. Now remember, I said when we add and subtract, we need a common denominator. So the first fraction has x plus 2. The second fraction has x plus 2, x minus 2. The common denominator means both denominators have to have exactly the same thing. Exactly the same. My common denominator here, not going to write a highlighter. The common denominator is x plus 2 and x minus 2. So both fractions need to have both factors. If we look at this original fraction, the original fraction only has x plus 2 in the denominator, but it needs x plus 2 and x minus 2. So whichever factor that I added to the denominator to make a common denominator needs to also go in the numerator. So adding and subtracting, whatever you add to the equation needs to go in the numerator and denominator in order to not change the algebra. The second fraction already has both factors, x plus 2, x minus 2. So I didn't, quote-unquote, add anything to the fraction. But this first one, x minus 2, was missing in the original, so I had to add it to the first fraction to the numerator and denominator. So then now that we have a common denominator, we can just add. So distribute the 5. So we distribute the 5, and then now we just combine like terms. So 5x plus x is 6x. Negative 10 plus nothing is negative 10. We've got our answer. So adding and subtracting, common denominator, and then combine like terms in the numerator. Leave the denominator alone when you're combining like terms. Okay, so this one, number 2, we are also adding, so I need a common denominator. The first denominator is 12y. The second denominator is 4y. So the common denominator here is 12y. And I know that because 4y I can turn in to 12y. How can we turn 4y into 12y? We multiply 4 by 3. So if you multiply 4y times 3 will give me the 12y that I need. So this one's a little weird because we're not in binomial factors, but you just need to have the common denominator on both sides, and in order to have the common denominator in number 2, we need to multiply my denominator by 3. And since I multiplied it by 3, I have to add the 3 to the numerator as well. So now, just like the last one, I need to distribute, and then after I distribute, I can combine like terms. And when I combine like terms, I get 4x minus 7 over 12y. So add and subtract, common denominator, combine like terms. Just for the sake of the screen, I'm going to jump to number 4. Alright, or sorry, number 5, I can't count. So, number 5, that dot is a multiplication symbol. So, I'm not adding or subtracting. You only need a common denominator when we're adding and subtracting. That's it. Not multiply, not divide, not solve. Just add and subtract. So multiply, we want to factor everything you can. Everywhere you see an x squared, if you have two terms that have a common term, factor everything you can, and then we're just seeing what we can cancel out. That's it. Okay. So I need to factor this, and when I factor that, I get x minus 8, x plus 1. I need to factor this, and when I factor that, they both have a 3x in common, so that leaves me with x minus 8. I can't factor 4x, and then I need to factor this, which is x plus 1, x minus 1. Remember, these, we just take the square root of both terms. So the square root of x squared is x. The square root of 1 is 1. So I know it's x plus 1, x minus 1. All right, now when we're multiplying, now that we have everything factored out, we make a mega fraction. And we put all the numerators in the numerator together, all the denominators in the denominators together. And then we see what we're allowed to cancel out. So I have x minus 8, x minus 8. I have x plus 1, x plus 1. I have an x right here and an x right here. And then I can't do anything with the 4, the 3, or the x minus 1. So whatever doesn't cancel out is my answer. So multiplying, we factor absolutely everything we can, and then after we factor everything we can, we simplify. Okay. Number 6, easier version of the exact same thing. So I can't factor x plus 7. I can't factor x plus 2. I need to factor this, which is x plus 3, x minus 2. And then I can't factor x plus 3. So when we're multiplying, we factor everything we can, and then we put everything in the numerators of the separate fractions in the numerator of a mega fraction. So we have x plus 7, x plus 3, x minus 2 over x plus 2, x plus 3. We see what we can get rid of. So we have x plus 3, x plus 3. And that's it. So my final answer is x plus 7 over x minus 2 over x plus 2. So factor everything you can. simplify what you can, and whatever you can't get rid of, that's just your answer. Alright, so now I'll scroll down to the bottom half of the front page. So, number 3. Again, add and subtract are the only time we need a common denominator. Only add and subtract. So number 3 asks me to subtract. So since number 3 asks me to subtract, I need a common denominator. The first fraction has an x plus 3. The second fraction has an x plus 2. The common denominator is both things. The common denominator is x minus 3, x plus 2. What I add has to go in the numerator as well. So the first fraction only has an x minus 3. But it has to have x minus 3 and x plus 2. So the x minus 3 has to go in the numerator as well. Here, the original fraction only has x plus 2, but it needs x minus 3 and x plus 2. So the x minus 3 that I added needs to go in the numerator as well. If you want, I can put what I add. So what I added to the original function here, I'm going to put in green just in case you need to see it better. Except I erased the wrong thing. Alright, so the first fraction is kind of a mess because I started erasing the wrong thing. So the first fraction was missing has x minus 3. I need it to have x minus 3 and x plus 2. So I have to add x plus 2 to the top and bottom. The second fraction has x plus 2 in the original question. It needs x minus 3 and x plus 2. So I had to add the x minus 3 to top and bottom. That way I have the same common denominator. Then we distribute. So we get x squared plus 2x over x minus 3, x plus 2, minus, then we got to distribute the 5. So we get 5x minus 15. And then once we have a common denominator, we're just combining like terms. So I have x squared minus nothing is x squared. And then I have 2x minus 5x, which is negative 3x. And then we have 0 minus 15, which is plus 15. So we end up with x squared minus 3x plus 15 over x minus 3x plus 2. So we need a common denominator only when we add and subtract, but we need a common denominator, and then we combine like terms. So number 4, in order to identify my common denominator, I have to factor the quadratic because I have to know what its factors are. So it's x plus 3, x minus 2, minus x minus 1, x plus 3. So the first fraction has an x plus 3 and an x minus 2. The second fraction only has an x plus 3. So my common denominator is going to be x plus 3 and x minus 2. So the first fraction has x plus 3 and x minus 2. The second fraction in the original only has x plus 3. So the x minus 2 I have to add to the numerator and the denominator. So it's missing x plus 2. x minus 2 to have a common denominator. So I have to add that to the numerator and denominator of the second fraction in order for them to have a common denominator for me to be able to add or subtract. In this case, subtract. So now we need to distribute. So the first fraction is just 2x. I don't have to do anything there. The second fraction, you need to distribute your terms. And we get x squared minus 3x plus 2. And then now that we have a common denominator, we've got everything distributed, we can just combine like terms. So 0x squared minus x squared is negative x squared. 2x minus 3x is 5x. 0 minus 2 is negative 2. That's my answer. So adding and subtracting, you need a common denominator. Whatever the common denominator is, but you need one. Whatever one of the fractions is missing, it needs to be added to the numerator and the denominator of the fraction that's missing whatever it needs to be common. So add it to numerator and denominator only when we're adding and subtracting. Okay, division. Division, we factor everything we can. So this top, we have x minus 11. No, we don't. Yeah, we do. X minus 11, x plus 2 over x minus x plus 8, x minus 3. Sorry, I'm trying to factor quick. Divided by x plus 2, x minus 3. So, the only difference between multiplication and division, when you divide fractions, you flip the second fraction and multiply. So this changed to multiplication, and the second fraction gets flipped, gets turned upside down. Then it just turns into multiplication. So in multiplication, we make a mega fraction. Everything in the separate numerators goes in the big numerator together. Then everything in the denominators goes in the denominator together. And now we see what we can cancel. So I have an x plus 2 and an x plus 2. I have an x minus 3 and an x minus 3. So the only thing I'm left with here is x minus 11 over x minus 8. So, division. You factor everything you can, just like multiplication. But we need to take our second fraction here and flip it. When you flip your second fraction, this just turns into a multiplication problem. So you squish all the things in the numerators in the numerator of a big fraction, multiply everything or put everything in the denominator of the individual fractions in the denominator of a bigger fraction. Number 8, same exact question. So I'm going to do everything in one step. I'm going to factor, but I only have to factor once here. So I have x minus 7, x plus 2 over 18x. This second fraction needs to be flipped. And I don't have anything to factor here, so that's good. And then now that it's multiplication, we put all the numerators together. And all the denominators together. So I have an x plus 2, an x plus 2. I have a 6 and an 18, which simplify but don't totally go away. And I have an x squared and an x. So the x squared doesn't disappear, but the squared goes away and we just have an x. Because x squared divided by x is just x. So I'm left with x minus 7 in the numerator. 6 divided by 18 is 1 over 3, so the 3 is going to be in the denominator, and everything else in the denominator went away. So, multiplying and dividing, factor out everything, and then see what simplifies. But when you're dividing, you need to flip the second fraction before you multiply. Alright, so after these 4 solving ones, we'll be done with the bulk of it. Okay, so there's 2 solving techniques we know. We know how to cross multiply, and we know how to find my least common denominator and multiply the entire equation by that LCD. So this first one, we can only cross multiply if we only have 2 terms. Lucky for us, we only have 2 terms here. So in number 9, I can cross multiply. Again, you can only cross multiply when you have 2 terms, a fraction equal to another fraction. So we have 3, 2 minus x equals 5, 1 plus x. So cross multiplication, you cross multiply, and then they're equal to each other. So we have 6 minus 3x equals 5 plus 5x. And then we just need to move everything over. And x here is 1 over 8. I ran out of room, so I'm not showing my steps, but you had to add 3x to the other side and then divide by 8. Alright, so number 10, I have 3 terms, so I have to solve by least common denominator. I can't solve by cross multiply, again, because I have 3 terms. Your LCD is whatever you need to multiply by to completely get rid of all fractions. So, in the first fraction, I need to cancel out x plus 3. So, I know x plus 3 is a part of my LCD. In the second fraction, I need to cancel out x. So, I know x is a part of my LCD. In the third fraction, I need to cancel out a 2 and an x. Well, I already have an x in my LCD, so I don't have to put x again. But I do have to cancel out that 2, so I need to add a 2 to my LCD. Okay. So now, we copy the equation. But we're going to multiply the entire equation. Multiply the entire equation by the LCD. So we're going to multiply it by x plus 3, x, and 2. X plus 3, x, and 2. X plus 3, x, and 2. So we multiply the entire equation by my LCD. And now we see what we can cancel out. So the first fraction, x plus 3. The second fraction, x. And the third fraction, x and 2. So the reason we're multiplying by our LCD is to completely get rid of all these rational functions. So all my fractions, or rational expressions, all my fractions are gone. So the first, what I have left over is 2x squared. The second, what I have left over is 4x plus 3. And then over here, I'm just going to go ahead and distribute the 5. So I have 5x plus 15. Then I need to distribute my 4. So I need to distribute my 4. And since I have a quadratic, since I have an x squared term, I need all of this on the same side, because when I see a quadratic, I know, or I should know by now, since we've been doing this since September, I should know by now that I need everything on the same side, and I'm going to factor to solve this. So 4 minus 5 is negative 1, and then 12 minus 15 is negative 3. So I need to factor this out to solve it. So we know we need to factor it. So after I factor the quadratic equation, I get 2x minus 3 and x plus 1. And then to actually solve this out, I need to set both of these equal to 0. And we get x equals 3 over 2. And x equals negative 1. Alright, on number 11. Well, actually, when solving, take the extra 2 seconds and double check to see if my answers are extraneous. So here, I can't divide by negative 3 in this fraction, and I can't divide by 0 in these fractions. Or x can't be that because it will make me divide by 0. So in this equation, x can't be negative 3 and 0, if we remember from our Unit 9 test. I didn't get negative 3 or 0 in my answer, so both of these are good. They're fine. So on to number 11. Number 11 is a little tricky because we need to factor this. 2x plus 8, I can divide them both by 2. So I'm really looking at 2x plus 4 there, not 2x plus 8. 2 times x plus 4. So if you can factor the denominator, we must factor the denominator before we move on. We need to identify our LCD again. So LCD. In the first fraction, I need an x plus 4 to cancel out x plus 4. The second one doesn't have anything we need to worry about because the denominator is a 1. The last fraction, the third fraction, on the other side of the equal sign, the denominator is 2 and x plus 4. Well, I already have the x plus 4 taken care of, but I won't be able to cancel out the 2 unless I add a 2 to my LCD. So we need to write the entire equation, and just for time purposes, I'm going to pause the video, write the entire equation, but I won't solve anything. Alright, so we write down the entire equation, and we have to multiply the LCD by every term. So, in green, I added 2 times x plus 4 to all 3 terms. And here, x plus 4 cancels. Nothing cancels in the middle because there's no fraction. And over here, the 2 and the x plus 4 cancel out. So now in this first fraction, all I have left is something I need to distribute. So that's 4x plus 14. In the second fraction, 2 times 2 is 4. So I have minus 4 times x plus 4. And then in the last fraction, we just have 2x plus 20. So then I need to distribute this negative 4. So here, 4x and negative 4x actually cancel out, so that's nice. And then 14 minus 16, so those cancel, and then 14 minus 16 is negative 2. So it'll be minus 20. And then 2x equals negative 22 divided by 2. So x equals negative 11. And then we have to take one more extra step and look at my domain. So x can't be negative 4 in this equation because negative 4 makes me divide by 0 here and here. I didn't get negative 4 as an answer, so negative 11 is fine. So remember, if you have a restricted domain and your solution falls in that restricted domain, that's what we call extraneous. So on the last one, we need to factor eating quadratic in the denominator first so we can see better what we need to cancel out. So this is x squared minus 5. And when you factor this, you get x plus 1, x minus 1. And then I don't have to factor what's in the numerator, only denominators when we're solving. So you can leave that third one alone. It doesn't factor anyway. Now I need to identify my LCD. So I need to identify my LCD. And the first fraction only has a denominator of 1, so we don't have to worry about that. The second fraction has a denominator of x plus 1 and x minus 1, so I know I need both of those things. The last fraction only has an x plus 1, so I already have the x plus 1 in my LCD, so I don't need the x plus 1 again. Now, I'm going to pause it again to write the equation. That way I can save a couple minutes of y'all's time. Alright, so we multiply everything by the common denominator. And then nothing cancels in my first fraction because it's not a fraction. X plus 1 and x minus 1 cancel in the second fraction. And then in the third, only x plus 1 cancels. So now, this looks like a cubic equation, which is going to be fun to distribute. So if I distribute what's in green first, I know that that's x squared minus 1. There's no right way to distribute here, so just make sure you're distributing everything out. I'm not going to sit here and explain how to distribute, but this x goes to all three things. Then negative 1 goes to all three things also. I'm going to pause so I can do that real quick without taking 2 minutes. Okay, so when you distribute the right side, you're left with x cubed plus x minus 2. I need to distribute right there. So that's x cubed minus x plus x squared minus 5 equals x cubed plus x minus 2. We need to move everything to this left side. So I need to move all this over. So I have minus x cubed minus x plus 2. And then I'm going to have to go to the right because I'm kind of out of room. Hopefully, if you look at the key on my desk, the work isn't as jam-packed, but it might be. I don't remember. So my x cubes cancel out, so they're gone. Negative 1x minus 1x is negative 2x, but I'm going to put x squared first. And then minus 2x minus 3 equals 0. So all that mess that we had with the cubic and all that distribution you just had to do turns into a pretty easy quadratic to factor. So we have to factor anytime we have a quadratic. That's how I knew I needed to move everything to one side, is we're going to have an x squared, so I know I need to factor. To solve, when you're solving an x squared, one side of the equal sign needs to be 0. So you have to move everything to one side. We set these equal to 0. So we get x equals 3 and x equals negative 1. We need to take our last extra step and plug in to see if any of our answers are extraneous. So when we do our domain of our original, I'm looking for a spot, but I'm kind of stuck. I'll do it right here in black. Right here. X can't be 1 or negative 1, because 1 or negative 1 will make me divide by 0. Well, if we go back and look at our answers, we got negative 1 as an answer, and we can't have negative 1 as an answer because that makes us divide by 0, and the word for that is extraneous. Sorry, I ran out of room, so I'll write weird. Is extraneous. So extraneous is if you algebraically find a value to be an answer, but it makes you divide by 0, it doesn't actually count. So just be careful and take one extra second and double check your answers to see if they're extraneous or not. So in number 12, negative 1 doesn't actually count. So my answer would just be 3. Alright, so we've got our last two. And luckily these are not lengthy explanations like some of the other ones have had to be. So, based on the graph of f of x shown to the right, what is a reasonable solution when, so A I'll do in green. So A says when f of x is negative 3. So that means when y is negative 3, what is x? So I go to 1, 2, 3, negative 3. So when y is negative 3, that's the green line. So when y equals negative 3, the x value is negative 1. That's all we're doing. On part B, I'll do in purple. And that's saying when y equals 1, what is x? So y equals 1 is here. When y equals 1, x equals 1. The test is long and has a bunch of solving, so hopefully this question can be a slam dunk. You're just going to the y value that I asked you to go to, f of x equals negative 3 or f of x equals 1. You're going to the y value I asked you to go to and telling me what the x value is at that y value. So moving on to 14. 14 is our only word problem. We have one that looks pretty similar to this on the test. So the total resistance for a parallel circuit with two bulbs, R1 and R2, is given by the equation 1 over total resistance equals the first resistance plus the second resistance. it's asking me to find the total resistance in the circuit if the first bulb has a resistance of 5, or the first resistor has a resistance of 5 and the second resistor has a resistance of 10. So I'm looking for R total, and it tells me that R1 is 5 and R2 is 10. So I plug in 5 for R1 and 5 for R2, and I'm trying to find the total resistance. So I need to multiply by my LCD. This looks like something 11, 12, 13, 14, or whatever the numbers were. 9, 10, 11, 12, right above it where we solved. So my LCD here, I need an R to get rid of the R in the first equation, or first fraction, sorry. And you can take a shortcut here, but I'll just go the long route. I need a 5 to cancel out the 5, and a 10 to cancel out the 10. And yes, if you're seeing something else we could do, you can do what you're thinking. I'm just going to go the long route for explanation purposes. So I write down the equation, but then I have to multiply every fraction by that LCD. So by R, by 5, by 10, and then we have 1 over 5. We're multiplying that by 5, by R, by 10. So we're multiplying by 5, by R, by 10. And now we look and see what can we cancel out. So I can cancel out my R, I can cancel out my 5, and I can cancel out my 10. And after I do that, I'll write what I'm left with over here. So 5 times 10 is 50 equals 10R plus 5R. So 50 equals 15R. Divide by 15. So 50 over 15 equals R. We can divide those both by 5, so we get 10 over 3 equals the total resistance.